Hey everyone, welcome to the 6th session of Designing for PoE Lighting and Automation. I'm just double checking my audio is on. This is the 6th session of Designing for PoE Lighting and Automation, where top design professionals and subject matter experts with experience in designing and constructing Power over Ethernet intelligent buildings share their best practices and lessons learned. This session will strategize how to leverage PoE automation platforms to integrate building systems, shades, and lighting to achieve sustainability and wellness standards. Through this and future sessions, you will gain crucial skills and knowledge essential to delivering better intelligent buildings for developers and owners. If you haven't already done so, please click on the link that I'll put in the chat line to register for the very last session, which will happen next week. I'm hitting on it right now. The next session is hosted by Joseph Earps from PoE Texas, who will show you best practices for operating and maintaining a PoE lighting and automation system once you have it installed. I am also excited to announce that this group, the people you've been watching for the last month, are presenting live at Bixie next week, as well as adding additional sessions on how to transform, for example, a building design into PoE lighting system, so you could translate drawings into a PoE lighting design, concepting new tech with IoT, and more, including Andy going into circadian rhythms, which is a very cool presentation. You can check it out in the link that I'll put in the chat line here in just a second. And here's the best part: you can join it all for free. Yep, that's the right price. Now, if you've missed any of the sessions, go back and watch them at the link that I've put into the chat line right now. I've watched the speakers make these presentations. I've watched all of the presentations to date, and I am still taking notes for our business and opportunities at home. They are super valuable sessions. Now, with all that business taken care of, and without further ado, let us meet our speaker and presenter today. Andy Rittenhouse is currently a specifications manager with Somfy Systems, a world-leading supplier of motorization and control solutions. Andy's focus is on commercial business solutions relating to window coverings and natural daylight management. Andy achieved his WELL AP in January 2020. Andy started his career in the solar shading industry in 1999 in Houston, Texas. Andy has served on the NFRC 100A and 200A 210 window attachment subcommittees. He has been conducting seminars and training nationally for the recognition of dynamic and automated solar shading for over 15 years. With that, Andy, I'm going to turn the presentation time over to you.
Great.
Thank you very much for presenting for us today.
Thank you, sir. Let me, so thank you again, Tyler, for the introduction. Welcome back to those who have been following our webinar series over the last 5 weeks. If you're new and joining us for the first time, like Tyler mentioned, we encourage you to follow the link that Tyler's posting so you can go back and watch the previous 5 presentations, which were incredible. I learned a lot myself, but it's well worth your time for some great information. So over the last 5 weeks, we've heard from various experts in the industry on subjects like roles and responsibilities, who, what, and when, best practices, network considerations, smart build, what a smart building is. And those are really important because those brought together a lot of missing parts or pieces to the conversation. But today I want to challenge you to think about why. Why are we doing this? Why not just stay with the status quo? It works. We know, how systems are in place with traditional power and technology. So why even go down that road? And so we're going to challenge you with some new thought processes, specifically dealing with how we can use the new technologies to better measure and monitor these systems for enhanced well and lead strategies relating to circadian lighting. Okay, so it's easy to say we care about improving our built environment, we care about, you know, sustainability and well, but we have to ask ourselves, are we just checking a box, or are we really trying to achieve that? And if we are, we have to look at some of these new design strategies relating to new technologies to really get there, to be able to validate that conversation. One of the things that is really driving this right now is the green building rating systems and standards. And so there are several green building rating systems and standards being used to help create sustainability and healthy buildings, such as LEED, WELL, the Living Building Challenge. And though the criteria from program to program for integrated automated shades and lighting offer impressive synergies in achieving these standards and certifications. So PoE, one of the great benefits of PoE is that we can use multiple types of data that will react in real time, allowing for the different subsystems to work together efficiently compared to siloed or standalone systems. And through that, we help them compete, or rather than the systems working against each other, they can work with each other. And we're going to expand on that here a little bit more. The other part about PoE, when we talk about these green building rating systems, is that PoE will enable integrated strategies such as the use of robust natural light as free energy when applicable, by reducing the energy use of artificial light and optimizing the circadian lighting systems within the offices. So we can use the two systems together to minimize the use of electric lighting, maximize natural lighting, to achieve some of these standards. You know, when we look at this and we talk about these standards, we want to keep in mind that yes, within the standards, they even address manual shading, right? But we have to think about this. And when I challenge you to think differently today, manual shading really is our biggest competitor to proper natural light management and measuring successes in sustainability and wellness efforts. Manual shading is sometimes used because of the assumed extra cost of powering automated shades without consideration of the negative impacts of the circadian lighting system. But we have to ask, what's the real cost or loss of value when the circadian lighting system has to compete with manual shades and left in one position or inefficiently positioned during the day? So technologies like PoE are going to offer a convenient, intelligent, information share and low infrastructure cost solution. So now we can use real data to help us manage these systems to get to where we want to be in our well and sustainability standards. All right. So we're going to talk a little bit about the Wellbuilding Standard, lead strategies, some practical applications, and standard examples. As we go through this, again, it's our intent today to highlight and hopefully produce some thought processes on how PoE can help us reach some of our goals relative to lighting and shades in our digital buildings of the future and really our smart buildings of today. It's not really the future anymore. And how the real-time data can help our subsystems be more efficient working together as we look at those initiatives, such as LEED, WELL, and Net Zero. All right, so the Wellbuilding Standard. The Wellbuilding Standard focuses on people inside the built environment, including exterior features that enhance the human-centric experience. Light is one of the main drivers of our circadian system. That is our natural time clock, right? So circadian lighting at its core is a natural effect. And so with recent technical advantages allowing for artificial light to mimic or enhance the benefits of natural lighting, we can utilize the combination of both. And PoE allows us to utilize the multiple types of data in real time so that we can use both natural and artificial light to ensure our indoor environments is properly synchronized to our circadian rhythms. A good example of this would be an article I just read recently on sundowner syndrome. And sundowner syndrome is something that affects persons with dementia or Alzheimer's. And that condition is enhanced at night when our circadian rhythms are off. And we see that a lot in the evenings because we've been exposed to improper lighting during the day, whether it be in our offices or even our homes or our healthcare facilities. If we're not exposed to the proper lighting conditions during the day, in the evening our circadian rhythms are off, that can have those kind of effects. So light within the Wellbuilding Standard is a very important part of this. We have, the lighting within the standard are going to have guidelines that are aimed at minimizing disruption to the body's circadian system and provide appropriate visual acuity. So lighting is a key part of this, both artificial and natural lighting, and it's specifically addressed in that concept. But we also have, out of the Wellbuilding Standard, in V1, we have 7 concepts, and 4 of the 7 directly relate to natural light and artificial light management. The second point would be fitness, or what's now called movement within the Well Standard. And the fitness or movement criteria promotes the integration of physical activity into everyday life. So what does that have to do with anything? Well, good example on that would be when we talk about design, is we have in our designs now staircases or stairs that are centrally located in lobbies or within our offices themselves to encourage us to walk between floor 1 and floor 2 or floor 1 and floor 3 instead of using the elevators. But if we want to encourage people to walk up the stairs to the next floor up, that stairwell or that stair system has to be inviting. It has to be designed in such a way that people are going to want to use it. And one of the key strategies within Well on that is lighting. And Well specifically calls out for a particular lux level using both artificial and natural light to brighten that staircase to encourage people to walk up and down. Now, if you don't, if it's just dimly lit or you don't address it properly with lighting, then you have the old backdoor staircase that nobody wants to go up. So this is another example of how within the Well Standard we can use the natural and artificial light combined together to achieve that standard. But if we're not using the advanced technologies, if we're not using integrated systems, how are we truly going to do that? You really can't have somebody going through and moving shades up and down based on the schedule they have on a piece of paper and says, oh, it's 12 o'clock, I got to go raise the shades halfway up. It's just not practical. And that's what we really want to kind of get across today, is how these technologies can help us achieve that. Another example would be the comfort criteria or the comfort concept within Well, which is going to establish the requirements designed to create distraction-free, productive, and comfortable indoor environments. So the trick with the comfort concept within Well is that interactions between the multiple environmental factors that matter most can be a very complex issue, since human nature and comfort is very subjective. It means, things like not everybody will be equally comfortable under the same condition, whether it be lighting, temperature, humidity, which are all subjective features that can be better managed through a single network solution. So when we talk about the comfort aspect of this, if we're able to measure and monitor our built environment, and we allow for user or occupancy input on a daily or a weekly basis, the building can learn. It can learn, okay, this particular comfort zone, this is where we need to be with our lighting, our artificial and natural lighting management, and our HVAC controls, while still providing local control. So we still have local control, even though the building is going to manage this. We still need to have that local control for comfort as well. So we can have the best of both worlds. But if we don't have that technology, if we don't have that integrated solution, yes, we can still achieve some of the criteria in well and lead, but it's really not efficient. I mean, how do you really do that? How do you, if you're manual or unautomated or unintegrated, you've got a thermostat on the wall and somebody's going back and forth, changing the air conditioning, or you got somebody, oh, it's too bright, so I'm going to go through and I'm going to raise the shade, or oh no, now it's too dark, I'm going to, bring it the other way, and it's back and forth. And that results in inefficiencies and distraction, right? You got people messing with the window coverings in the comfort zones rather than focused on what they're supposed to be doing, which also leads into the mind concept. And the mind concept within the Wellbuilding Standard requires that we have design, technology, and strategies that are designed to optimize our cognitive and emotional health, and by promoting the use of sensor technology. So those 4 concepts within Well alone have multiple strategies, and each one of the strategies is going to be enhanced, again, when we use technology like PoE, where we can measure and monitor the environment and get real data to help us make informed decisions. That feeds into lead. Now, lead and Well have a lot of synergies. Within lead, so Well is going to deal with the human factor, the health and the comfort factors of the people in the building. Lead is going to address more of the built environment. Okay, lead is going to deal with efficiency, sustainability within the built environment, but shades and lighting have a lot of synergies within this. And you'll see if you really dig into lead, you'll see that both lighting and shades have touch points in the integration process, energy performance, daylighting, thermal comfort, interior lighting, minimum energy performance. And you can see here by this slide, there are substantial points available when we use these strategies. But how efficient can we really be, right? How can we, when we, move away from the integration process, we move away from the efficiencies of this. And so when we look at strategies within lead, dealing with innovation, that can help us generate long-term revenue and short-term costs. We look at things like sustainability and Well. They score very high, especially with the younger generation workforce. Healthy and sustainable workplaces are going to make your business more marketable to a larger workforce pool. These are all really important aspects. But if we're not integrated, if we're not using the new technologies, we're again not going to be efficient. Okay, so the lead process, we can do things again like create sustainable and Well initiatives that will allow us to cut costs by optimizing our resources, coordinated planning, reducing change orders, bringing together the stakeholders to have a common conversation to meet our goals. Okay. PoE shading solutions. When we talk about shades specifically, shades, of course, are a subsystem within a bigger network or a bigger solution. And when we talk about shades being a subsystem that can offer both local and automated control to meet the comfort and automated daylighting strategies, the real-time data share through PoE management software not only manages the light and glare, but then can also include the occupant or user inputs relating to the comfort, such as evaluating how others use the local control versus the automatic process. Now, when we get into the conversation of the new technologies and PoE and Well and Lead, shades are another great example to where the challenge has always been, and we ran into this with the NFRC window attachments group years ago, The challenge is, and I get this asked a lot, is I'll be asked, well, if I put shades in my building, I put motorized shades in my building, where's that going to save me money? How much money is that going to save me off my electric bill? And the mindset is traditionally along the lines of, oh, well, shades are going to reduce the solar heat gain coefficiencies, and it's going to save me money in that area. The problem is when we use our traditional methods or older methods of shading versus, via manual or even just a motorized where you're clicking just only have local control. The problem is we have no good way to measure, monitor that. We have, the standards that we created back with the NFRC window attachments task group we used back in 2010, we used single pane windows because back then that's all we had. We used a 3% openness fabric. And so you had one scenario that everything was based on. And if you tried to go back and say, okay, well, let's create it so that we can validate our discussion, so that we can validate the performance of shades in a building, you literally would have to go through and take every type of piece of glass with every different type of fabric, with every different type of openness factor, measured at every different type of openness, as far as, whether the shade is 20% up or 50% up or 100% up or vice versa. So all those scenarios leaded up to hundreds of different types of tests that would have to be done. And it just wasn't practical. And so we have that in our buildings with both shades and lighting. There's so many variables that go into play when we're trying to do this manually. It's really hard to have a justified conversation. But when we use strategies or we're using technologies like PoE, now the buildings are going to give us real-time data so that we can make informed decisions. So when we go and we talk about PoE shading solutions, yes, we talk about cutting infrastructure costs, which are really important. And in a lot of markets we can, because we can reduce conduit, we can save time. It's going to be more efficient relating to building codes and construction renovations. We can conserve energy by utilizing proper energy management systems, which will in turn really, we have things where, obviously if you're using the natural light as much as possible, you're going to reduce the cost of your overhead lighting, things like that, improve performance. So those are all really important, but it really comes down again to the data share and being able to use real-time data to help inform decisions. All right. So the technology that's being applied to many of these applications, making buildings smarter and more efficient, would be an example like shading, HVAC, and lighting. Okay, the integrated data from these three systems provide real-time feedback and control based on the set parameters versus all three being standalone or trying to communicate through three different languages or translators. It's inefficient. The integration of these systems is not new, but again, the traditional methods such as dry contact, RS-232, doesn't really facilitate a charrette or a stakeholder group meeting that will bring the various stakeholders together for a conversation for efficiency. And what do I mean by that? As an example, if you have multiple systems coming into play, you would have someone like maybe your installation team, right? Going out and they're installing insulation based on their requirements. And then you have your HVAC guys coming in and they're installing HVAC based on their criteria. But if they're standalone, if we're not communicating, your HVAC, if they don't know what's going on with your insulation side, they're not really having a good informed decision. Same thing with shades. If your shade dealer is going out and they're just called for motorized shades and they're installing motorized shades, but they don't know what's going on with lighting, all of a sudden you have two systems there that could literally compete against each other because shades and lighting didn't communicate to find out what the common goal was going to be. So when we bring in these new technologies like PoE, we're having a joint conversation to come up with a one solution for the project. Data collection, cross-system efficiencies. I've talked about data collection multiple times here already today, but this is really key. This is when we talk about, well and lead strategies and where we can benefit from this technology, and it really comes into the data collection. I'm sorry, I didn't mean to click that already. With the data collection, we can use multiple types of data that can react in real time, allowing for different subsystems to work together efficiently compared to siloed or standalone systems that can compete or work against each other. Example, like the daylighting portion of windows that are designed to maximum daylight versus the view portion, which is a lower portion that deal with the views to the outside. So if we utilize intelligent systems and real-time data between the systems, will allow for the full potential of the designer's intent for the windows and window coverings and the lighting systems within the building. Conference room management, smart active workstations so that they can clean those and open for use in a free address floor plan. So what we mean by that is, and that gets away from the shades and lighting, but it plays into the data collection part of this in the fact that we can use that. We can use this information like with our active workstations. We can scan and say, okay, this, I was just here, I leave, and it's not going to let somebody else scan in until that's been cleaned. Things like that add to our healthy workplace. Designing offices for spatial considerations. This is again, going to be really important when we talk about our design and how we can design for future considerations. So if we have good data from this project we just did, we can use that data to help us design the next project in relation to natural light, things like custom zones for localized occupant comfort and control, entrance management, depth entrance management, things like that can be really important, being able to take good data and move it for our spatial considerations. Well features. So here's some specific examples. When we talk about well feature 53, visual lighting design, that says that we need to maintain an average of light intensity of 215 or more measured on a horizontal work plane. The lights can be dimmed in the presence of daylight. That's important, right? So when we look at this and we look at visual lighting design and look at, again, minimizing the use of our artificial lighting by maximizing the use of our free energy, of our natural light, and using a combination of two so that they balance out. So the other feature that we look at within Well is automated shading and dimming controls. That's feature 60. And that calls for design features such as adjustable window shades and lights with dimmers that must be actively managed to be effective. And I'll say that again, they must be actively managed to be effective. Automated controls that can help ensure these systems continually operate as intended to meet the intended benefits such as glare avoidance and energy reduction. Furthermore, setting these features to automatically adjust can greatly contribute to comfort without disrupting the occupants from other tasks. So what we want to do is we want to prevent glare and encourage the reliance on natural light through automated shading and dimming. If we can automate the process, then we're gonna reduce the disruption. We're going to be more effective, creating a better environment for both health and sustainability. And then, of course, we're going to be able to measure and monitor that. When we talk about LEED, when we go into LEED, and we can spend hours getting into each specific standard, and so, but these are just a couple examples. Like here, credit 7 daylighting. The intent of this credit is to connect building occupants with outdoors reinforce circadian rhythms, and reduce the use of electric lighting by introducing daylight into the office space. And to earn this credit requires inclusion of manual or automatic glare control devices in regularly occupied spaces. So I have this up here because, we also have to look at, in addition to glare control devices, supporting simulations or measurements must be completed to prove that the design achieves certain daylighting objectives. So when we look at that, we have to ask ourselves, okay, well, they include manual glare control devices, but then they also say that we have to support it with simulations or measurements. Well, how do you really do that with a manual system? And that's where the inefficiencies really come into play, because if you're going to try and do a manual shade, but yet you have to support the measurement of that, where are you going to get your testing from? Valid testing, not testing done 10 years ago on single pane glass or one type of fabric, but you literally, to do this correctly, you're going to have to go through and you're going to have to know exactly what type of fabric, what type of glass, and find a test that showed the effectiveness of that, which you're really not going to be able to do. That, or you're going to have somebody going through with a little checklist, or 3 times, 4 times a day, moving shades up and down based on certain times of the day and reporting that, which again is very inefficient. Okay? Whereas if we have an automated system, the shades will react during the day based on the timed events or sensors, and then allowing the lighting to react off of that to maintain the balance that we're trying to achieve. So to kind of wrap up today's discussion, we want to keep in mind that sustainable development means that humankind should satisfy its current needs without compromising the ability of future generations doing the same. We can do this through reuse, repurpose, planning for future technologies, and modular designing to minimize our future footprint for future improvements and renovations. So if we're planning for the future and we're planning for future technologies, we're able to minimize our footprint. What I mean by that is, if we use the right infrastructure and we put that in place now, 5 years from now, when you're having a tenant improvement or a renovation or a reuse of that building, you don't have to open walls, or the footprint of that remodel will be far less, because we already have important infrastructure there. Where if you're just trying to do something that, this will work for now without considerations of the future, in the end, it ends up costing you more. And that's where we get into the discussion of things like life cycle costing, things like that. So we want to keep that in mind. Within our well buildings, with proper system integrations and data share, we are able to measure and then improve the quality of our air, water, light. We know how to design environments that fuel our bodies and keep us moving, inspire our best work, facilitate a good night's sleep. But we also have to understand that our workplace environment flows into our home living. It's not like Vegas. What happens in Vegas stays in Vegas. What happens in our office building follows us home. And our circadian rhythm that is in place, or the status of our circadian rhythm when we leave that office is going to follow us home. And we have to keep that in mind. So the two do relate to each other. And it's very important. And that just adds the importance of doing this design correctly for our offices to benefit the wellness and sustainability within the system. So to sum it up, the PoE ecosystem will provide the infrastructure that can help us achieve the goals and standards in the most efficient, healthy, and sustainable way possible by providing the real data shared between the systems. So with that, I'll wrap it up. If we have some questions, I'll be more than happy to answer questions. Not that, I'll turn it over to Tyler. Do we have any questions, Tyler?
Well, yeah, everyone get your questions submitted so we can ask Andy these questions. So Andy, I think the first question that came up is, um, where do you apply for, or how do you, like as a user who's implementing it, how do you apply for and demonstrate that you comply with LEED and wellness?
So both rating standards have scorecards, right? And so whether if you're trying to achieve a well certification, you're going to go to Wells Internet, the well building website, and we can send you that exact link offline. And same with green. So GBCI has a website that you'll go to, and you'll get a scorecard. And usually the process is going to start with your charrette or a stakeholders group to talk about the goals of the project. You're going to talk about, here's our project. Here are our goals. We want to be energy efficient, or we want a healthy building. And here's some of the areas we want to address. And here's some of the areas we would like to address. And then you would follow that scorecard, and it would give you an initial kind of like a guide that you can expand upon. So, but there are scorecards that will help you through that process.
Great. And then how do you approach management? You said that design charrette. How do you approach management and quantify the value add for the LEED and the wellness? You talked a little bit about that, but can you give us more specifics? What's the approach for quantifying and qualifying this for your management?
Well, that's in this particular discussion, it is tricky, because with lighting and shades, it really is heavy on the comfort factor, and comfort is so subjective, and it's really hard to measure up till now. So up to this point, before we started talking about these new technologies, there was really no way to validate that. So if you're going to an owner or your manager and you're trying to say, hey, we need automated shades, or we need shades and lighting integrated together, or we need a PoE solution, it's a hard conversation, because there's not a lot of precedent. We don't really have a lot of data to say, look, this is the result we're going to get. And so we have to go back to the earlier conversation of really talking about, look, what we do know is that most markets require circadian lighting systems or daylighting systems to be in your building. We know that, right? We're going to have that. And we also know that if you have a manual shade system, it's going to be very inefficient. So if you leave your shades down all day, your daylight harvesting system, how can that really be efficient if your shades are left in inappropriate positions, or only moved once a day or once a week, right? And so you have to try and get them to understand, if you really want to make your daylighting system efficient, we have to look at the windows. We have to manage that natural light. And that's really trying to get your management to see shades in a different way, rather than just a window covering dealing with solar heat gain, but rather as a natural light management system. And they have to buy into it, right? And we see projects, we still see projects where they're out there talking about, oh, this building is going to be the country's newest building dealing with sustainability and and they have manual shades specified in it. It's counterproductive, because everything's going to start at that window, and it's hard, because there is going to be no solid data to have that conversation. They're going to have to buy into or truly embrace the well and LEED conversation, and see the vision, I guess.
Okay. There's a question here. Are there any standards that mention the use of PoE? Is there any benefit or in terms of points that you can get by using PoE either for LEED or well?
Great question. And not that I am aware of or have seen. I have looked extensively. I think though that there would be a case in the innovation section. So both Lead and Well have opportunities for new technologies and innovations. And I think that a case could be made for using PoE to achieve one of those credits by going down the road of the conversation of, look, if we use this technology, we can actually measure and monitor the system to validate what we're saying. So, but it would have to be a joint effort with key stakeholders going down into an innovation credit.
Yeah. So I think we have time. We've got one last question here. What's a good strategy in your experience to balance the energy value of dim lighting with the quote-unquote threat of forced open shading that may cause irritating sunlight? I think we're talking about glare, disruptive sunlight, and how is the highest value occupant productivity maximized? How do you balance that for an occupant in the space?
It's hard, right? And a lot of that is going to be, if I understood your question correctly, a lot of that is going to be based on the user input, because it's very subjective. The amount of light coming in, and are we getting glare from the buildings at certain times of day? Is it a channel glare, only hitting a few certain workstations? With the new technology such as PoE, we can use the user input to help us manage that. Because if we don't, there's really no way. Because I could be sitting at this desk, this workstation right here, and I'm enjoying the light, the sun, and the energy coming through, and the person next to me could be like, oh, it's too bright, I don't like it, right? And we use within our strategies, one of the things that can be used is, if we have those kind of conflicts, we'll use like task lighting, right? You can use localized task lighting for if in a particular comfort zone, everybody's comfortable with the temperature and the general lighting, but maybe the person next to me wants a little bit more or less, we can use some task lighting for that, right? Glare itself is a little bit trickier, but it's very subjective. And if we have input, if we got good input and good data, we can adjust. So if the system based on the input, if we know every day that this group or this comfort zone or this group of people in this zone are uncomfortable every day because of glare alone, we know we need to adjust the motion. You know, there are sensors that will deal with that, but again, you can have sensors saying the glare is good, but I may not like what the sensors are having to say. So if we can input data and information and experiences, the building can learn from that.
Very good point. Okay. Well, I think we've got most of the questions answered, Andy. That was really great, my friend. So I'm going to flip my camera on here, and we'll get this all wrapped up. So thank you, Andy. I would say to everyone out there, we often get so wrapped up in the cool factor of PoE and the automation and what you can do with PoE, we miss the real practical values of a system like this. And what Andy's talking about is those practical decisions and comfort at the individual level. So with that, everyone, we have used our time, and I believe we've used it extremely well. So don't forget to follow the link in the chat to see and register for the last session. Seating is limited. And if you would like, you can speak to Andy either by letting us know in the post-session questionnaire, where you can tell us how to make these training sessions better, or you can email him directly, which I'm showing right here. So it's very generous of Andy to be able to be willing to share his email address and his time with you. And thank you for coming. We will see you all next week. Don't forget to try and catch all of the presenters at Big C next week, or at sessions we're hosting on YouTube with PoE Texas for the Bixie Show, and we're looking forward to seeing Joe next week. So thank you, Andy. Everybody give Andy a nice shout out, thanking him for his time and the effort to put this presentation together, and we will see you next week.